In this video, I am going to discuss about electric field due to two infinite parallel sheets of charge. And before we start this topic, first I would like to remind you, in the study video I was given to you the electric field due to a infinite plane sheet of charge, this one, and suppose this one is a sheet of charge and its surface charge density is suppose sigma. Then at any point near this sheet of charge, electric field on either side of it, either this side or this side, is given by E is equal to sigma upon 2 epsilon naught. And the electric field is always perpendicular to this sheet, and if the charge is given positive, then direction of the electric field is always away from it. And if the charge is negative, suppose for this sheet here charge is negative, and suppose its surface charge density is sigma, then in same way the electric field due to this sheet of charge at any point near it, either this side or this side, is given by E is equal to sigma upon 2 epsilon naught. And if the charge is negative, then electric field is towards it. So electric field due to infinite parallel sheet of charge be always perpendicular to this sheet, and if the charge is given positive, then away from the sheet, and if the charge is given to the sheet is negative, then towards the sheet, which already I have discussed in the previous video. Now let us consider two parallel sheets of charge having the surface charge density are sigma 1 and sigma 2. Here I am taking different value of surface charge density sigma 1 and sigma 2. And suppose both sheet is given to a positive charge. And our aim is to find electric field at any point between these two parallel sheets of charge and at any point outside the sheet of this charge here. It means any point between these two sheets of charge means either P, and outside the sheet of charge either P dash or P double dash. Let P be a point at any point between these two sheets of charge. But don't think here P is not only the midpoint. You can take any point between these two parallel sheets of charge. And remember this, the electric field due to a parallel sheet of charge does not depend on the position. If near the sheet of charge at any point you will calculate the electric field, then its magnitude will always same, which will be sigma upon 2 epsilon naught. So first we will take at point P. It means our aim is to find what is the net electric field at the point P, where this point P is lies between these two plates. So for this purpose, first we will find out what is the electric field at point P due to the first plane sheet of charge, and again the electric field at point P due to the second plane sheet of charge. So at point P, electric field due to sheet 1 is due to this one. Since its surface charge density is sigma 1, and you know the formula for this electric field intensity, suppose that electric field intensity is E1, so that E1 is equal to sigma 1 upon 2 epsilon naught. And since the charge given to the sheet is positive, so electric field due to this sheet of charge at point P, whose magnitude is sigma 1 upon 2 epsilon naught, and it is what here, away from sheet 1. It means forget this one, all these things you forget this one here. Only you take electric field due to this sheet of charge at point P is E1, this one whose magnitude is sigma 1 upon 2 epsilon naught, and due to this plane sheet of charge electric field is away from the sheet 1. And electric field due to C2. Suppose that electric field is E2. So for the second parallel sheet of charge, electric field at the same point P due to this sheet of charge, suppose that electric field is E2, then its magnitude is given by sigma 2 upon 2 epsilon naught. It means, forget this electric field here. The electric field only due to this sheet of charge at point P is E2, which is directed away from this sheet of charge, means away from the C2. So here, away from C2. And now you see here, at the point P, the electric field due to this plane sheet of charge is E1, whose magnitude sigma 1 upon 2 epsilon naught, and directed away from this sheet, means away from this first one, or you can say away from this sheet 1 and towards 2. And same way, the electric field due to this second sheet of charge at point P is magnitude sigma 2 upon 2 epsilon naught and directed away from this sheet, means along this one here. And net electric field at point P, since both electric fields are acting in opposite direction, so here you will take net electric field is bigger one minus smaller one. Suppose sigma 1 is greater than sigma 2. If sigma 1 is greater than sigma 2, then you can say E1 is greater than E2. Here I am suppose this one. If sigma 1 is greater than sigma 2, so net electric field between these two parallel plates is equal to E1 minus E2, and which is equal to sigma 1 upon 2 epsilon naught minus sigma 2 upon 2 epsilon naught. And here you can say this is equal to 1 upon 2 epsilon naught, and this one is sigma 1 minus sigma 2. This one is a net electric field between these two parallel sheets of charge at any point. Once again, I would like to remind you, don't think here that this one is only the midpoint. Anywhere you can take between these two sheets of charge. If sigma 1 is equal to sigma 2, it means if the surface charge density of both sheets are equal, then net electric field at any point between these two sheets of charge E becomes 1 upon 2 epsilon naught sigma minus sigma, and this becomes 0. It means at that time the electric field due to these two sheets of charge at any point between these two plates will be 0. In same way, at point P dash or P double dash, means any point outside the sheet, we can also calculate the electric field due to these two plane sheet of charge. So electric field due to sheet 1, which is E1, either at point P dash or P double dash, is equal to 1 upon 2 epsilon naught, and this one is sigma 1, or simply you can say yes, sigma 1 upon 2 epsilon naught. And at this point P, forget this one, only I am considering the sheet 1. So due to sheet 1 at point P dash, electric field E1 magnitude is sigma 1 upon 2 epsilon naught and directed away from this sheet. It means away from sheet 1. Similarly, electric field due to sheet 2, either at point P dash or P double dash, at both point you can say E2 is equal to sigma 2 upon 2 epsilon naught, and this one is also away from C2. It means if we consider the point P dash, then electric field due to this first sheet of charge at point P dash is E1 away from this sheet, and at point P dash due to the second sheet of charge, which is E2, is also away from the sheet. It means both will be act in the same direction. And in same way you can find the electric field at point P double dash, which one is E1 and E2 due to seat 1 and 2, and also directed away from both seat, means due to 1 and due to 2. So this will be also act in the same direction. So net electric field at point P or P dash. So net electric field, net electric field at P dash or P double dash, which is net electric field E, which is equal to sum of these two electric field E1 plus E2, and this becomes 1 sigma 1 upon 2 epsilon naught plus sigma 2 upon 2 epsilon naught, and this becomes 1 upon 2 epsilon naught sigma 1 plus sigma 2. And if sigma 1 is equal to sigma 2 is equal to sigma, it means if suppose the surface charge density of both sheet are equal, which is equal to suppose sigma, then E becomes 1 upon 2 epsilon naught sigma plus sigma, and we can write here 1 upon 2 epsilon naught into 2 sigma, 2 is cancelled by 2, and this becomes sigma upon epsilon naught. It means if the both sheet having positive charge, then electric field between these two sheets of charge at any point is equal to difference of their electric field, and outside of these two sheets of charge is equal to sum of their electric field. So in this way we can find the electric field due to a two infinite parallel sheet of charge.